Right, guys, now that we have looked at trigonometric functions and discussed the inverse trigonometric functions, I think it's important now to look at equations. But like I said before, it's going to be very important to understand the notion of a reference angle. But using that again, it is important to notice that the values of trigonometric functions, they just oscillate, like they are periodic, they repeat themselves. Maybe they might change depending on the sign. Now, for example, let's say I've got an equation which says sine t equals to, let's say maybe 3,6. Can sine t be equal to 3,6? Sorry? Why? Because sine t oscillates to the 1 and 1. So immediately I'm given such an equation, I can see that that thing is upset because sine will never be equal to 3,6. Is that right? Okay. So let's say sine t equal to 0, 1, 2, 5. What we know is that this function is going to be positive where, like for example, looking for sine t, so a sine function, it's going to be positive where in the first and the second quadrant. What are we looking at? We are looking at the coordinate y. It's only important to look at the coordinate y. In the first and the second quadrant, that function is going to be equal to a positive ratio, isn't it? Now we can then assume that there is an angle here, which is t, just taking the one in the first quadrant, and we call that reference angle. All together, guys. Now, after I've done that, I can now sort of write my new kind of helping equation, which I say sine t0 equals to 0, 1, 2, 5. Having that in mind, I know that if I reflect this arm on the other side of the equation of the y-axis, I reflect it this way, I'll know that this angle is going to be reflected there, and I'm going to have t0 there. But for this equation which I was given here, this equation which I was given there, let's say it was said to solve it between 0 and 2 pi. This is 0 radians, and again when I go right round, this is 2 pi on that line there, on the horizontal. Is that right? Do you understand what I mean there? I start from there, say, go around 0, 3, and then come 2 pi again. All together. Okay. Then, for this equation, I should understand that I need to find the two solutions. This one, angle, and that angle. But what am I doing here? What am I doing here? I'm just setting up an equation as if I want only this angle. Now, when I've solved for this angle, I can now get this other angle by saying pi minus this t0. Then I've got the two solutions. Am I making myself clear there? So what I'm going to do now, I'm going to continue now at this point here. And now say, since I've got a reference angle here, I know I'm in the first quadrant, I'm now going to apply the second function sine and say sine second function of sine t0 is equals to sine second function of 0, 1, 2, 5. This side we apply our knowledge of the composition of a function and its inverse, isn't it? So then we say now this is T0. Then we go to our calculator. Maybe in our calculator we'll have to press a key which is written. I think first of all we press second function, then we press a key which is written sine. You will see somewhere on the top there will be second function sine, isn't it? So then when you key that, then you key 0,125. I'm explaining this according to the manual of my calculator. What I'm trying to tell you is that you must go back to the manual of your calculator and find that the sequence of pressing the keys is not exactly the same like my calculator. Are we together? Okay, then what are you getting there, guys? 0,125. The second function of 0,125 is 0,125. The value is 0,125. Okay, 0,125. Can you tell me something on that note? This 125 and that 125, is it the same number? What is this first 125 here? It's a reference angle, isn't it? And the second, this one? No. This is not a reference angle. What is this? No. This 1,25 here. Is that an angle? What is it? It's a ratio. It's a sine ratio, isn't it? It's just a mere coincidence here that the sine ratio and the angle, they are numerically equal, isn't it? It's a coincidence. I don't know, maybe we are pronouncing the calculator wrongly, but I hope it's correct. So now we get that T0 being that. That is a reference angle. Now we come to the solution. I've already given the structure of the solution. One solution is T0 and the other one is that, isn't it? Then I'm going to write here. Therefore, T is equal to 0,125 or T is equal to, what is that? What is pi minus 0,25? What are we getting? Pi minus 0,125. 3,016. Is that right? That is the solution between 0 and 2 pi. So this equation is solved between 0 radians to 2 pi. If I were to give a general solution throughout the domain of sine, I would then say one solution set is T equals to 0,125 plus 2k pi. Why 2k pi? Remember we said these values repeat themselves every 2 pi. And then the other one will be T, or T equals to 3,016 plus 2k pi. What kind of an animal is k? What type of an animal is that? It's a number which is supposed to be an integer. Are we together, guys? So that is the solution between 0 and 2 pi. That is the solution in full. Questions? Yes?
When you split T0 on the side and T0 on the side, it's the same T0.
It's exactly the same T0. Listen to what I said. I said the value 0,25 is the ratio which you are talking about of that angle, this one. But that 0,25 will be 0,5 for this angle T0 and the other angle which has got a red arm there. But now how do I know that this angle which has got an arm there is this? reflect this side, this arm, across. You understand what I mean by reflection? You reflect it there, this angle is going to be reflected there. So in size is the same T0. But how does that T0 help you? It helps you then to tell you that the angle which terminal side is on this radar must be pi is there, minus, you see, and now I'm moving in negative direction, minus T0 going that side. That's why I put this calculation there. Am I making sense? Okay. You must always try to figure that out. Are we together?
If with this equation, what would you ask like a question? What would it be?
This equation, what would it be?
Yeah.
In this case, I can say solve this equation.
So if you solve sin t equals to
Solve the equation sin t is equal to 0.25. Find the solution. Then I'll give you the range, because this equation has got infinite solution. There. This is this infinite set solution, this one. But now, because it's got infinite solution, I can now give you a range within which I want the solution. Then I say here 0 to 2 pi. Are we together? Are you following me? Okay. Now, what I want to do at this moment is to look at this same equation when this ratio is negative. That is important for me. Are we together? Okay. Right, guys, now let's look at the situation where this ratio here is a negative ratio. Even if that is the case, I'm not going to stop using my reference angle story. I'm going to say, okay, let's have sine T0 equals to 0.125. Check what I've done, guys. I've taken that equation, ignored the sign, and used the reference angle and said 0.125. Like I'm going back to the initial equation. All together. Now, there is the angle, the reference angle. There is the angle. But now, I know that sine is going to be negative where? In the third and the fourth quadrant. What am I looking at? I'm looking at the sign for the coordinate y here. It's negative. And there it's negative. Remember, sine is defined from y and r. R is always what? Positive. So it's negative there. Then what happens there? It means the angle I'm dealing with is an angle which I'm dealing with this angle. Shout if you don't understand why. That's the angle which where the ratio is negative. Altogether. Okay. Then on the other end also this y which is negative here, if I reflect it across that, I'll have another y here over the same r, which is going to give me the same ratio. Altogether. Are you getting what I'm saying? Y here, horizontally, and y there are the same. So which means I've got another angle whose terminal side crosses there, and this angle, in this case now, I'm talking about this angle. Shout if you don't understand. Do you understand that? Everybody? Sorry? Nobody's going to talk for you. Listen, this is not like in politics where people go and talk about for our people. No. Here you talk for yourself, guys. Talk for yourself. If you don't understand, just tell me. I don't understand what you're talking about. Anybody? You can say it in capital letters. Are we all following what I'm saying? Okay. I got an equation with a negative sign. Then I start analyzing where could be the solution for this equation. I say the solution for that equation must lie at an angle whose arm lies in the third quadrant there. Or an equation which lies where? In the fourth quadrant. Because y, x sign is defined in terms of y, that's where y is negative. All together. But now what do I do here? What am I doing here? What I'm doing here, I'm trying to take the advantage of the reference angle. Now if that is the angle, I just extend that line up to there. Then when I say if this was the angle, I know that this was the angle. Then I extend it across, I got there. Then what I'm going to get here between x and that extended arm will be the reference angle, and with an acute angle which is in the first quadrant, and a value which I can actually compute from the calculator. You understand what I'm saying? Okay. So now once I've got that, I set up this equation. Then I go to my calculator and I use my inverse function. What I'm going to say now? I'm going to say sine second function sine t0 equals to sine 0,125. Are we all there, guys? Sorry? Sorry? Okay. The other time when I started raising my voice, I was actually looking at a face which was telling me silently, I don't understand. But I don't want to pick on somebody. Then somebody says, no, why pick on me? But please, guys, come up if you don't understand. Now, inverse function here will give us t0. Then what is it going to give us? We say it is going to give us 0,125. Good. So what is that? That is this angle. Now, using vertically opposite angles are equal. Do you see that? So which means this angle here is t0. Now, having that angle being t0, it helps me now find the angle which terminates here, which I want. Because I know up to there, it's what? Pi. Then up to there, it will be pi plus this t0. Are we there, guys? So now I'm going to say one solution here is going to be t equals to pi plus t0. Then I substitute my t0 and find the angle. Are we together? But when I come this side, check. This angle normally will be reflected across the x-axis. This will be t0. These are straight lines, isn't it? If you understand reflection very well, that will be t0. Are we there, guys? Then at the end of the day, the angle which terminates on this arm here would actually 2 pi minus t0. So the other angle there is, I can say this one, or t equals to 2 pi minus t0. Question: am I making myself clear? Are you sure, guys? Yes? Come again? Why is the reference angle 0,125? I thought you calculated it from a calculator.